very small amount of information that's actually in RAM at any one point in time.
Yeah, and patch tag, you know, the darks repos are not being kept in massive in memory. They're being kept on the file system.
Divisionist and massive is another optional piece of HAPS, right?
You don't have to use massive with HAPS, that's right. And actually, I was going to say, the first time I saw HAPS was at a big commercial bank. Jeff Pollicott, I believe, gave a presentation on using HAPS with several different database systems at Deutsche Bank. I worked on that project too. And he decided not to use massive. Yeah, he used it for, because it was Haskell, because it had like the nice way of stringing together controllers. And he just used it to control all his databases, basically. So no, you don't, it's not specifically database friendly, but I think a lot of the people that are currently hacking on HAPS and are on the IRC and like are doing a lot of stuff are maybe more massive friendly. But I would like to see, you know, one of the things I might do is I might ask, you know, Jeff if any of this stuff could be sort of fed back to make it easier for the next person that wants to do it. But there's a lot of good database libraries already in Haskell. And basically, if you're interacting with a database, this is an I/O value type, and HAPS can do anything in I/O. You know, it can print you a file, it can give you a beep, or it can do whatever you want with a database. You just stick it in I/O, and it's like, you know, pretty flexible.
So, you know, the person that would traditionally probably go and say, wow, this is really cool, would be someone who had to go through the agony of going, oh, the database is not scaling, and they optimize all the queries, and they're like, oh, it's still slow, let's throw hardware at it, oh, that's still not working, damn. And then they have to like install memcached, and then finally they're like, okay, now it's going fast. That kind of person this would be ideal for that person, because then they wouldn't have to build all that stuff in between. It's a solution that gives you what the end result of using memcached in the first place, without having to go through all those things.
But it's not good if you have a lot of business logic that's already in a database.
Yeah, obviously.
So I'm not sure whether you could even do something like this, but the Seaside solution, or the current Seaside solution, is you take an object database and just put your entire app plus the framework inside the database of stored procedures.
Well, isn't that part of the small talk philosophy, kind of like everything started in the image?
Yes, but you actually have originally a lot of people ran up with an external database called Gemstone. Gemstone realized, hey, you could just shove all of Seaside into the database. You get persistence for free, and persistence sharding and everything for free, plus no IPC to slow things down.
So what, they put Gemstone into Squeak? I don't understand.
And Gemstone is the object database.
Is that part of Squeak now?
It's like an alternative to Squeak.
Oh,
Yeah.
I see.
So it doesn't only run on Squeak these days.
Oh, okay. So Gemstone is like
Gemstone is
the small talk compatible.
small talk engine that happens to be really good.
And it has sharding and multi-master
Yeah.
and all that stuff. Okay.
That's not so easy with Haskell yet, because they sort of oriented towards compiling static code, you know, and so there's some cool stuff you can do with loading dynamic code, but it's not kind of this forte in the way that it is. So it would be a little hard to store your HAPS web app in HAPS massive storage, for example.
Yeah, that sounds pretty hard.
But it sounds like it would be cool to do.
Actually, I guess the thing is more, you take I guess the closest you get in this case is having, I suppose if you were to take Massive and add this sharding and intelligent caching, with this as the primary store, you get a similar effect. And in the case where you have enough memory to hold the entire data set, that just reduces to everything in memory.
Sure. Did you follow that?
You're saying that.
So suppose that you've got more data that can fit in memory, such that you need to swap.
Well,
ordinarily that would kill performance, but if you restrict the amount of stuff that you have in memory and just load stuff off disk intelligently, that would allow you to keep the performance.
true. That's interesting you say that, because I was thinking of, in my head, that One way to solve that problem would be to simply make the swap file size really big and let the memory manager choose what it thinks is not being used, which is usually pretty good. Because remember, I mean, Haskell is compiled, so it should be able to make the same kind of inferences that it makes with other programs.
There's a reason that databases have their own cache systems. Just in terms of non-local access. But that's it.
Well, so I still want to thank you guys for the first invited speakers talking LFP, and
Any more questions? We'll take like one or two more before this gets too intense.
Something from like the so we were talking about kind of massively scaling it, but sort of on the other end. So I kind of set up HAppS for a kind of small site I was working on. With I mean, it's just a and I was trying to think like what's the cheapest that I could like spend in terms of like hosting per month to do this, and it turned out to be like not that great because like I actually needed to like get a virtual server. Like HAppS doesn't really have a functioning fast CGI front end, although that probably would. It seems like there was one that rotted maybe, but the real problem seemed like, and so I put it on a virtual server, and at first I tried to get the cheapest one I could get, and the site as it runs only uses maybe like 20 megabytes of memory in RAM, like the process uses. But compiling the program, like GHC compiling the program and linking it, turns out to use like several hundred megabytes. And that actually killed it and actually caused me to bump. First, I had to switch to from whatever the virtual host used to Zen so that I could use swap. And then I had to bump it up again just to get it to even.
Where are you hosting your site, by the way?
It was VPS Lite, I think.
Okay.
Yeah.
How much is that?
Well, it's kind of funny you mentioned that
because
because we've been having the same problem as far as like the compilation seems to is very memory intensive, and that's just a thing with GHC. The heap can get kind of out of control, crazy sometimes, depending on what you're compiling. And so the way we've kind of learned to work around that is now we have like a dev environment kind of like on our own system, and we compile the binary and then we just upload the binary and run it. I mean, as long as you're running on a similar Linux platform, that will work just fine.
So me on the Mac machine.
Yeah. And I mean, even with really meager VPS, let's say you only have like 128 RAM or something like that, unless you'd have to have a lot of data, and it'd have to be really fat data to fill that up very fast. But the compiling, I agree, does take a lot of memory.
Yeah, so I guess if you're on a Mac and you're serving it on Linux, then this won't work. Then basically you're talking about the minimum being $20 a month, I think.
Yeah, that was my sense. There's some like compiler. It turned out I think the linker would. It was like even just compiling Cabal install like wouldn't work. Like forget about like my actual application. And I found some like linker flags to LD that made it much less memory intensive, but it's still like I needed to be on the 256 megabyte machine.
Okay. Is there any more questions? Like one more, or just we're good now? Okay, cool. Thanks for letting us.
Thank you, everybody.
Guys.